dreaming anymore. All that I know is I'm falling.
Okay, so now let's do an example where we go backwards and we actually decompose a logarithm, like take it apart, using the sum and difference properties of logs, but going backwards instead, okay? So here we have ln, that just means the natural log, right? So we're just going to treat it as a normal log. So we have ln of x to the fourth y divided by 7. So the first thing we see inside the log is that we have something being multiplied times something else. So the x times 4, so let me rewrite it as this. So x to the fourth times a y, and then all of that is being divided by a 7, right? So the first thing that I want to address is get rid of this 7 on the bottom. So let's break it up. And because we see something divided by something, in order to go backwards, that would take us back to the difference of logs, right? So this is going to be equal to ln of the top thing, x to the fourth times y, minus ln of the bottom thing, right? And there I just went backwards using our difference of logs property, okay? So now that we have that, the ln7, we can't really do anything with that, so that's good to go. But then here we see that we still have something being multiplied times something else, so that means we can break something up again, okay? And here, because we have a product going on, two things being multiplied, this is going to take us back through the sum of logs property, okay? So we're going to say, okay, so ln of x to the fourth times y minus ln of 7, that's going to be equal to, so to break this up, this breaks up into ln of x to the fourth, and then plus ln of y. And we have that plus sign there because we're just going backwards from the sum property of logs, okay? And then that minus ln of 7 is just kind of sitting there. And the very last thing, if we want to, we can always take this exponent here and just use our normal exponential property of logs and bring that exponent down in front to make it even simpler. So 4 times ln x plus an ln of y and then minus ln of 7. Okay? And that's how you break that original term down into logs. Alrighty, so here we have a kind of cool physical application of logs, because right now it seems like, okay, I guess they're sort of cool, just as mathematical objects, but here there's actually an application to chemistry. Okay, so we actually have that this formula is one frequently seen in chemistry, is that pH is equal to negative log of the H plus concentration, or the H plus ions, hydrogen ions concentration. So we're given this formula already, so that pH is equal to negative log, and this is with base 10, it's our common log, of the concentration, whatever that is, of our H plus ions. Okay, so this is a given formula, and the question is asking if the concentration, so this guy, if the concentration in a liquid is doubled, what is the effect on pH? So if you double this guy, double this, something happens and it does something to the log, and then it transforms the pH in some way. And we're trying to figure out, okay, what does it actually do to the pH? So the first thing is, they don't give us an actual concentration or a numerical concentration of hydrogen ions to start with. So let's just say we start with C, okay? So this is what we're going to start with. Start with C, and then we're going to calculate the pH there. So then we're going to find P, the pH, okay, which is pH, okay? And this is the concentration. Alrighty, and then we're going to double it. Okay, so then we're going to plug in 2C. Right? Because then that would give us 2 times the concentration. And then we'll figure out what is our new pH. Okay, so this is what we're actually solving for. So let's work with this column first, this start column. So all that means is that our pH, our original pH, which I'll denote with a P, is equal to negative log, we don't have to write the 10 because that's the common base, right, of C. Okay, and C just represents our starting concentration, whatever that is. We don't know what exact number, but it doesn't really matter. Okay, so we have something like this relation here. Okay, that's good. And now what we want to do is plug in double the amount here. So now our new P, which I'll just write new P, is equal to our new pH is equal to negative log of 2C. Okay, and now it's like, okay, well, what is that? Isn't that the answer? Because our new P is just equal to this thing. But no, we want to write it in terms of how it affected our original pH, right? So we want to have a normal P in there somewhere, okay? So what we do see is that this log, we're taking a log of a product of two things, right? And now that we know the sum formula, or the sum property of logs, we can actually break this up. We can break it down a little bit, okay? So our new pH, is equal to negative times log. I'm just going to keep the negative outside for now, just so we don't get super confused or anything, okay? So we're just going to break down this thing in the box into log of 2 plus log of c, okay? And then now we can distribute the negative sign, okay? So now we get that the new pH, or the new p, is equal to negative log of 2, and that's just a constant, minus log of c, okay? So that's good because we actually recognize this term right here, right? Negative log of c is actually our original pH that we started with, right? So we can replace this bracketed thing with a p, okay? So the new pH is equal to negative log of 2 plus whatever our original pH was before we doubled the concentration, okay? So that's basically it. Our new pH is going to be equal to the original pH and then minus log of 2, okay? And if you actually plug that into a calculator, we'll get something like this. So new, if I can write the word new, pH is equal to the original one minus log of 2, right? And then, like I said, if you plug that into your calculator, you'll get something around 0.301. Okay, so that is how doubling the concentration of hydrogen ions here affects our actual pH. Okay? Okay, now for the final example for this concepts video, I'm going to show you guys a way that we can utilize log properties in solving equations. Okay, so here's an equation that we're supposed to solve, and solve means find x by itself. Okay, so here we have two logs, so log of 50x plus 25 minus log of x is equal to 2. So the first thing we see is, okay, we want to get x by itself, but how do we get it out of the logs? So the first thing we have to do is consolidate this whole left side, right? We want to get the x's together, which means we have to get the logs together, okay? And we can do that because we see a difference going on, like subtraction, right? So we know that this is actually going to be log of the first thing, okay, divided by the second thing, okay? And that's how we combine those two logs, using the difference property of logs, okay? And then on the right side, that's just simply equal to 2. We didn't change that in any way. We just kind of reformatted the left side, okay? And here, because we don't see an explicit base written, it's implied that we're using the common log, which is 10, base 10, right? So if we have kind of like a 10 going on here, what we can do now, in order to get rid of this log entirely, is exponentiate, it's called. The act that we're doing right now is called exponentiating both sides by base 10. Okay, so then in doing that, these ones cancel out, which is what we want, and on the right side we just have 10 squared, which is 100. Okay, so that the right side equals 100, and then the left side is just 50x plus 25 over x. Okay, and now all we have to do is just solve for x, so we'll multiply by x on both sides, so they'll cancel out on the left side, so we get 50x plus 25 is equal to 100x. If we subtract 50x from both sides, subtract, then we get 25 is equal to 50x, and if we divide by 50 on both sides, we simply get x is equal to a 1/2. Alrighty? And that is how you solve an equation involving logarithms, using logarithm properties. Alrighty, so that does it for our concepts video on logarithmic properties. I hope that helps, and I'll talk to you in the practice problems video if you watch.